Hello, everyone. So, welcome to this showcase. So, today, Mireia from Soltec will be telling us everything about the new tracker. So, the Sf8, and right. So, as we'll be recording this, and we'll be sending you the recording and the presentation. But we have a tradition here at ATA that before we during every showcase, we tell everyone where we're connecting from using the chat function. So, right. So, Mireia, over to you.
Thank you, Carlos. Hello, everyone. Thank you very much for being here. Let me share my screen now. Okay. Yeah. Can you see it?
I can see it perfectly.
Okay. Hello, everyone again. Thank you very much for attending, and thank you, ATA, for giving us this opportunity here to present Soltec new Sf8 solar tracker. My name is Mirilla Jimenez. I'm product manager in Soltec, and we look forward to give you guys the updates and the enhancements that we have been implemented in the new product. Soltec, making tracks, building trust is one of our models. Soltec is not only a provider or manufacturer of single-axis tracker, but we also are a provider of VOP services, which is one of the features that our company that makes us unique. We've been around in the industry for 16 years now, and we've expanded of our footprint in terms of not only in the products that we are able to offer our clients, but also the services and the different markets that we can complete those services. Soltec is a specialist in the manufacturing and supply of single-axis tracker. We also have a workforce of over 1,600 people around the globe. Our track record worldwide has reached 11 gigawatts, and the most recent year, in 2018, we sold 3.6 gigawatts of trackers. That made us the #3 manufacturer globally of single-axis tracker, putting us the #1 in Latin America with 30% of the market share, and #2 in Europe with 18% of the market share. This slide here provides a visual snapshot of our 11 gigawatts that we were talking before. You can see over 5 gigawatts in South America, North America over about 2.5 gigawatts, including Mexico and US. And we've been expanding in Europe, North America, Middle East, and Australia. This slide here speaks to Soltec's focus and commitment research and development. We've been focused on bifacial technology and on wind design. On having validated the wind tunnel test by our partner, RWDI from Canada, being that Soltec is the longest provider of two-portrait single-axis tracker, we see that we have a distinguished advantage to maximize the bifacial gain of the modules considering the structure. We've been doing a lot of tests, having BITEC, the Bifacial Trackers Evaluation Center, to identify what are the real factors that play into that bifacial boost to adapt our product and also to best advise our customers to design their systems. With RWDI, we've been answering the questions around wind design that previously seemed that were not fully covered by applicable building codes. That allows us to question the standards that are out there, and we created the IWID methodology with RWDI to have a proper calculation to make sure that we were supplying equipment that will be safe no matter what conditions it's put into. Now that we have presented the company, we're going to get to the fun part here and start explaining a little bit more of the Sf8 single-axis tracker. We are really excited to present this new product because we see that in terms of efficiency, we are going to take some major steps forward from everything, from how much power and capacity the tracker can hold to how quickly can be installed and other great efficiencies here. So as you can see here, the Sf8 has a similar architecture to the Sf7, the previous model. It is still a two-portrait tracker. The primary difference being that this tracker now will host 4 or 6 strings rather than only 3. This, of course, allows us to host a lot of more power with a lot of more modules per tracker. Another difference is that it will be a multi-drive system to be able to have much longer tracker that it is still robust, reliable under high wind conditions, and it has a new shape of his torque tube that allows us to increase the stiffness with the same weight. As I said, the main difference between Sf8 and Sf7 is that Sf8 will be able to host 4 to 6 strings. Just as a reference, for regular crystalline modules, that's around 100 meters, around 330 feet. We can do that with a multi-drive transmission system within the tracker structure and supersized torque tube with improved geometry. The new geometry of the torque tube has been designed taking into account the bigger size modules that we are seeing in the market for the next year. In Soltec, we wanted to be ahead, and for that, we have been able to increase the stiffness of the system 22% more than the previous SF7. Again, as I said, the Sf8 will have the transmission protected inside of the torque tube, so Sf8 offers the highest resilience to wind while keeping its elegant design, reducing the number of parts, and easing the tracker installation. Here we can see the new brain of the tracker. From the mechanical point of view of this new brain, we've improved the box to facilitate heat dissipation, and we've improved the attachment to the torque tube to make it faster. From the point of view of the hardware and the software, we have done the system exceptionally smart. Purely wireless field communications start from gateway device, which commands up to 200 tracker controller, more or less. And in the event of gateway failure, a redundancy of gateways in the system allows a surrounding gateway to dynamically assume control of the subfields at any moment to maintain functionality. Another thing to mention is that I don't know if you have set Google Home or Alexa app at your home, but if you have done it, you know how easy it is to install in your network, right? Just a few steps with your cell phone. The idea here is the same. The tracker controller is going to be able to self-commission. Our commissioning team will go tracker by tracker, waking them up, and they will know in which sector of the site they are and what gateway they need to obey. The other point is that we use OpenThread, developed by Google, to find the quickest way to send the information, tracker position or wind alerts, for example. So you have a dynamic mesh looking for the strongest signal to have the lowest latency. Here we can see how we'll be accommodating the string. We can see the example with 4 strings, but it will be the same for 6 string, adding 2 more to the table. Moreover, it's showing how to integrate our new bifacial theme track algorithm. Theme track was a product that we had already before that was our ability to have the trackers tracking at different angles at the early part and the late part of the day in an effort to avoid the shading, which gives additional energy in the curves, which can be very significant, up to 6.5%, as we'll see later, depending on the slopes that we see on a given site, and also integrating our diffuse stow. Diffuse stow is what, it's when you have a lot of clouds covering the PV plant, and rather than having the trackers follow the sun, when there's a lot of diffuse light, they will go to a flat position to maximize the amount of energy that they produce at those times. Diewind was something that I mentioned briefly early in the presentation, and it is the methodology that we have been using for a lot of years right now. We co-developed this with RWDI. RWDI, as a reminder, is a wind consultant based in Canada that has been responsible for some of the longest suspension bridges in the world, as well as the tallest buildings. What we saw in the last years was that certain wind design code standards applied to solar trackers are insufficient since they do not consider the aeroelastic effects. We found that it was necessary to come up with this new analysis methodology, and we've gone through peer reviews, not only with RWDI, but with other groups that are considered also experts in the industry. 3 types of wind tunnel tests has been carried out with RWDI, 1 rigid, 1 sectional, and 1 aeroelastic through the years. Thanks to the wind tunnel studies, it is concluded that The three most important mechanisms at the time of a tracker failure are these three. First, resonant vibration, which is the one that occurs in the adjacent row after the wind current hits the first row. In other words, all the vibrations and turbulences that are produced to that first shock. To evaluate this effect, we use the first wind tunnel that you can see here. The second and third mechanism, torsional flutter and torsional galloping that you can see in the picture below on the right, go hand in hand. They are concepts that are associated to mathematical terms, but just to give you an idea. The flutter is an instability that once it is produced, it feedbacks. Each time, the cycles of vertical oscillations are bigger, so that can end in the failure of the tracker. Torsional galloping is quite similar to fluttering, but it doesn't feedback. Anyway, in trackers, you have a higher load than if there was no movement of the structure. The movement that occurs in the structure due to the wind flow produces loads that are much bigger than those you have at the static level. So the second wind tunnel takes into account the second and the third mechanisms. And finally, with the aeroelastic wind tunnel, we have a triple check of all the above. So we're able to calibrate our CFD software for future simulations. It is very important to understand and to request aeroelastic studies when designing or choosing a tracker, because not all the manufacturers have done these types of studies yet. The Sf8 and the full wireless system don't come alone. We also offer our algorithm package, the team track. This includes the regular backtracking, the team track. I talked about this before, just considering the position of the trackers and the slopes of the site. From this one, you can produce up to 3.8%, sorry, more. If you add to this the diffuse strategy algorithm, what we call the diffuse stow, then you need to add an additional 2.19% more. And if you have bifacial modules with the proper versions of the algorithms for this scenario, then you need to add 0.52%. In total, you can produce up to 6.5% more just for using our tracker, two-in-portrait tracker with our algorithms, with the team track. Also, after 2 years of data of BITEC, our bifacial tracker evaluation center in Livermore, California, we've seen that the two-portrait tracker produces a 2.1% more than the one-portrait tracker. It was the Sf7, but we have kept all the advantages of the previous generation. So in conclusion, if you compare the Sf8 with the bifacial team track algorithm package versus a regular one-portrait tracker, Soltec produces up to 8.6% more, in ideal conditions, obviously. As we know, software such as PVSys uses simplified view factor models that are faster to simulate. These models assume many simplifications, such as the isotropic behavior of reflective radiation or design simplifications. Although inaccuracies are introduced, they allow construction features to be included in the form of parameters that can be adjusted. So the balance between accuracy and practicality is to calculate these parameters with ray tracing before and to include the parameters in PVSys. So even if we do not have an absolute an accurate precision, we can estimate annual production with some confidence. In the case of Sf8, it is necessary to adjust the values for structure shading loss, shade transparency factor, field thermal loss factors, and mismatch loss factors. One of the most curious findings of BITEC is realizing of the influence of natural air cooling over the bifacial gain. Temperature is a determining factor in energy production, and it is conditioned by the mode of installation. The differences in geometry between one-in-portrait and two-in-portrait trackers present differences in the behavior of the air and therefore in the effectiveness of its cooling. PVSys models this cooling by using a convective factor you see and another factor linked to the wind. This is the U sub V. We have calculated the use of C and use of V value based on the 2 years of measurements in Vitec. Analyzing the measurements at Vitec Center, the National Center of Renewable Energy here in Spain, recommends to use values of 1.3 for the use of C and 2.3 for the use of V. These parameters depend on the mounting structure, and thus G values should be recommended by the manufacturer. Values from literature are shown here in the first 2 columns in the table at the left bottom. PVCist recommends to use 29 and 0 for use of V. Well, it is important to understand that use of C and use of V work together, but we strongly do not recommend using use of V as 0 because we are neglecting a remarkable wind influence, which is important in large-scale PV projects, usually built in country areas. Other tracker manufacturers suggest values as 25 and 1.2 for one-in portrait trackers. And in the right, you can see the energy loss if you apply both configurations. As you can see in the Sf7 bifacial 2-in portrait tracker keeps a module cooler and allowed to yield around 1.3 more energy than the 1-in portrait tracker. Thermographies shown on the right were taken at Vitec for 1-in portrait and 2-in portrait bifacial trackers, operating under the same conditions. As can be seen, tracker cooling methods lead to module temperature distribution differences. Thermographies over several days show average deltas of 3.5 Celsius degrees between modules in tracker 1-in portrait and 2-in portrait. The upper module on the 2-in portrait tracker operates at a lower temperature than in 1-in portrait, whereas the 2-in portrait lower module temperature is quite comparable to the 1 portrait. Mismatch losses represent the electrical energy that we stop producing because the cells are not working in the same conditions. Bifacial modules have higher mismatch losses than monofacial modules because the distribution of the radiation on the backside is much more irregular than on the front side. Studies carried out by Soltec together with SunLab have quantified this module rear mismatch losses with a software called Duet that allows to go into comprehensive cell level modeling. Study results can be observed in the table on the left. For albedo 20%, we find a 0.06% energy loss. Meanwhile, on 60% albedo, we face a 0.32% of losses. According to the results, the PVCist rear mismatch factor that simulates these losses is set to 0.9% and 1.9% for each albedo value. As could be expected, there is a strong albedo dependency of the value of these parameters, and if we assume a linear performance, this value is assessed, the line formula you can see here, with a constant value of 0.4, with a 0.4 and a variable value depending on the albedo, multiplied by 0.025. Performing the same study for a 1P tracker, the rear mismatch factor obtained is 3.4%. PVCist has a default value of 10%. However, in the literature, we can find similar values offered for studies of 1-in portrait tracker and 2-in portrait trackers without a gap over the short tube. For example, for a tracker with no bearing or piles under the PV modules, the literature indicates 3.5%, very close to the 3.4% that we have calculated for a similar tracker in the Vitec studies. The shading factor is a percentage reduction of the rear radiation. In other words, it causes a shading interference in the backside. In the table, you can see different scenarios extracted from our studies done with other organizations such as SunLab or NREL, and other white papers from 1-in portrait trackers manufacturer. You can see that one imported trackers, even those optimized for bifacial, have higher shading factor values. This is a direct consequence of the design topology. A tracker that houses two modules vertically has less piles and less meters of torque tube per module. The elements that generate shading are mainly the torque tube, piles, and slewing drive. About piles, an in-depth study with SunLab incorporates a 3% radiation reduction in the module, considering the 6 piles that produce that produces a loss of a radiation of 0.7 in case of Soltec tracker. In the case of the torque tube, we have compared the results of NREL ray tracing simulations with a continuous shadow-free plane like the one simulated in PVSys, and considering the torque tube as well. As expected, this comparison presents totally opposite results for one imported trackers and Soltec bifacial trackers, with a gap between the modules to avoid the shadow of the tube. But you need to consider the gap over the torque tube and the output gain of 1.7% due to the access of the light through the gap. This surprising result is because of both no torque tube shading and a reflection effect on the torque tube. We can easily understand this effect looking at the graph in the left. Here we can see the value of the rear irradiance in a 2P tracker for 3 cases. The blue line indicates the ideal continuous free shading plane as the PVSys. The black one represents the irradiance distribution of the Soltec tracker with a black torque tube. In this case, we can see a central irradiance reduction. Despite the central gap, there is a minor shading effect in the border of the modules. Finally, the gray line shows the realistic case, a metallic torque tube. Central peak shows the reflection of our torque tube. We also have carried out simulations for 2P trackers and no gap that can be considered as a standard 2 imported tracker with a 5.5% shading factor. PVSys simulates collectors as an opaque surface. However, transparent backsheet modules, as shown in the picture on the right, allow some radiation to go through the space between cells. Module transparency fraction values should be provided by the module manufacturer. So when data is unavailable, some sources suggest approaching module transparency, named as MT, as the ratio between cell area and module area, according to the expression on the right. Well, sorry, just to mention to finalize this, a table on the bottom shows the final expression for our standard Soltec bifacial tracker. It includes the module transparency plus the 3.75% due to gaps in the plane multiplied by the 1.7% delta due to the reflection on the torque tube. To draw some conclusions from this presentation, we're seeing that the new Sf8 can keep the greatest installation tolerances without compromising stability at high winds, which is to say that we can still have steep slopes and some other terrain challenges. The new Sf8 SAR tracker is also reinforced to be 22% more rigid than the previous generation, so specifically designed to accommodate some 72 and 78 CELMS modules that are out there in the market. The David system is reinforcing the Soltec tracker to be able to face a lot of those adverse circumstances as well. And the full wireless system developed with OpenThread is also creating a much more robust communication system. Also, new Sf8 produces up to 8.6% more power than when mounted with bifacial modules in ideal conditions. Bifacial gain, albedo, and the new tracking algorithms all have been carefully considered as part of the Sf8 superior design to maximize performance. And lastly, the specific performance and advantages of bifacial modules can be simulated using available software such as PVSys if provided bifacial parameters are properly entered. So in Soltec, we are here to help everyone here to be able to simulate properly the tracker. Thank you so much. I think that I extended a little bit more, but
thank you, Mireia. That's okay. We have a number of questions here. So obviously, your presentation was very interesting. If you could stop sharing your screen for a second, and then maybe we'll have time to answer one of the questions. So what do you say? Should we answer the first, and then we'll I'm sorry that we won't have time to answer all of them, but we'll send the questions to you, Mireille, and then you can answer them offline.
Okay, yeah, we can answer the first one, for example, about
okay.
the multi-drive system. Yeah.
So the question says, we are interested in multi-drive systems. Could you explain a bit how do you control the torque each drive supplies to the tracker? Do you use stepper motors? Are they enough to control the torque of each drive?
Yes, we use we will have one motor and a transmission join its gearbox to be able to synchronize both. So that's our solution. Maybe.
Okay. Would you like to answer the second one?
I'm reading all of them.
This one about latency on communication systems, on-end costs compared with previous models.
Well, for the latency one, it's going to depend on the typology on the layout. Depending on the layout, it will be a little bit different, but obviously will be always have less latency than with other systems like Zigbee. In any case, we have solutions in those layouts that are more complicated and not very regular, that we could have a very large subfields anyway.
Okay.
And about the O&M, well, it's not going to increase, that's for sure, and probably it's going to reduce due to the reduced parts. We will have less electronic components and less motors, so that will save a lot in O&M services.
Right. Okay. And then maybe let's answer one last question. So
well, yeah, there's one that it needs more explanation, so I prefer to answer that via email because it has very deep.
The one on internal drive work.
Yes, exactly. How about the wind? It is done, but regarding the wind speed, the question says about the wind. Did you calculate the max wind speed acceptable by your tracker with larger modules? It is done project by project. It is done project by project because obviously we have the wind tunnel with our coefficients, but we still need to calculate it with according to the local standards, and depending on the locations, the wind loads will be different, and depending on the modules, the wind loads will be different. In any case, yeah, it is need to calculate project by project to see the maximum wind speed. Well, the maximum wind speed about the tracker. There's no maximum. It is. We need to calculate it for each project, and then we design the tracker accordingly. Just
okay. Mireille, thank you so much. And I think we have come to the end of this showcase. Thank you to everyone who's been with us today. It's been a very active showcase, and yeah, so we'll send the questions to you, Mireille, so you can answer them offline. And well, thank you for being with us today.